Hey everyone, so this is going to be the last lesson for Unit 12 where we're talking about logs. Here we're actually going to be talking about logs in the context of word problems essentially. We're going to see like real life applications, like how would you actually use log equations and all those types of things. So if we scroll down real quick, we can see the first question where we kind of did a question like this before. So they tell us that there's a population for this kid Jason's hometown, which originally had 75,000 people. So this is our initial value. And that the population is growing at a rate of 2.4% each year. Now, remember, we have our exponential growth equation, which is always going to be written in the form of a times 1 plus r to the x. So a is our initial value, which for us is the 75,000 people. Then we have 1 plus the rate. Now the rate's 2.4%, which means that this is actually going to be rewritten as 0.024%. 0.024 as a decimal. And all this is going to be raised to the power x. When I add this becomes 1.024x times 75,000. So the only one that matches that is going to be this one. All right. So that's all we have so far. And then part B, and so we've done that already. So we're doing part B. It wants to know how many years it will take for the population to reach 100,000 people. Now, this was something that I don't think we went over into too much detail, but now what we're going to do is actually solve this equation. So our final population is 100,000 people. We set it equal to this equation we just came up with. Now remember, to solve for x, when it's in an exponential, in the exponent, we're going to have to isolate the term. So I have to get rid of this 75,000 from both sides. I plug it into the calculator. Do 100,000 divided by 75,000. And you get 1.33 repeating. In order to get rid of that x, I'm going to take the log of both sides. So the log of 1.33 repeating is equal to x log 1.024. Remember, I'm taking that exponent and I'm putting in front. That's the main purpose of doing the log. Divide both sides by log of 1.024. So I have x being equal to the log of 1.33 repeating divided by a log of 1.024. And I end up getting to the nearest year 12 years. Now, one thing to note is that this 12 years, if I actually plug it into my original, well, I get 12.13 years. So the answer would be 12 years, because that would round down to 12. And that would be my final answer. All right. If I scroll down, we'll see a bunch more examples, pretty much doing the same idea, where we're going to be either writing the exponential equation or using our whole log setup to actually solve for that exponent. So here we have this equation that's given to us. So a equals 10 times 0.8 to the t. They wanted us to know how long it's going to take so that the original 10 milligrams that we had before in the beginning goes down to half, which is going to be 5. So they essentially want us to solve this equation. Again, I'm going to isolate the variable term. by dividing both sides by 10. So this becomes 0.5 equals 0.8 to the t. Take the log of both sides. So log of 0.5 equals t log of 0.8. Divide both sides by log 0.8. So I end up getting that t is going to be equal to log of 0.5 divided by log of 0.8, which gets me 3.106. They want us the nearest tenth of an hour. So 3.1 hours. Okay. Scrolling down to the next question. So here they give us this equation for the number of houses in a certain village, and the number of years are since 1995. They want to know when will the number of houses exceed 1,000. So I put 1,000 in for H. Do my same setup, isolate the variable. I get 1.85 take the log of both sides. And then from here, divide both sides by log of 1.039. So I get that t is going to be equal to log of 1.85 divided by log 1.039. And I get 16.11 essentially years. Now they want to know the number, what year this is going to happen. So the number of years starts from 1995. So I'm going to add 16 years to that. And that's essentially means that this is going to happen year 2011. Now down here, it says, how can we verify using the graphing calculator? Well, one way that we could do this is we could set, using the graphing calculator, set y1 equal to 540, 1.039 to the x. Set another equation to be y equals 1,000. And then essentially what we would do is find the intersection. That's pretty much the main way that you would do that. So you would do that, find the intersection. You could also look in the chart section that will tell you all the y values for different values of x. So you could always do that, scroll down until you see about 16 years. And that could also do it, but I think they wanted the answer to be to find the intersection of those two equations. All right, here's the next one. So they give us this, and they want to know when will the snowboarders be at least 10 million. Now, one thing to note is they want that these numbers, this 0.5, is in millions already. So when I use the equation, I'm actually just going to put 10 here. Do the same thing, divide both sides by 0.5. Take the log of both sides. Divide both sides by log of 1.21. So I I get x equals log 20 divided by log of 1.21. So I get it in this year. So this rounds to about 16. So starting from 1988, I had another 16 years. And I get the year being 2004. Again, how do we verify the answers? The same exact thing. We said our two equations, y1 equal to 0.5, 1.21x, and y2 to be equal to 10. And we just find the point where they're going to intersect. All right, this will be the last question, because from this point you should start to notice the pattern. All right, so here growth of some bacteria is given by this equation. You want to know how many hours it will take for 4 bacteria to increase to 25,000 bacteria. So G's our final bacteria, which is 25,000. Sorry, 2,500. A is our initial, which is 4. So divide both sides by 4. Six, 2, 5. Take the log of both sides. This becomes log of 625. Exponent drops down, log of 2.7. Divide both sides by, I'm actually going to do it all in one go, but you could divide it both sides by log 2.7 and then again by this fraction. So I'm essentially dividing by everything that's not the t. So I get that t equals to log of 625 divided by 0.584 times log of 2.7, and I got 11.098 hours. So to the nearest hour, it's going to be 11 hours. All right, and that's pretty much it. Yeah, there's no other follow-up to this question. So that's all these word problems are. Again, now instead of the original cases where they give you an exponential equation, they could have you come up with the exponential equation similar to this independent practice and similar to some of the other word problems that we've done. But then instead of solving for what the final value is given a certain number of years, now they're going to look for that exponent term. So you're going to have to use the log equations and how we solve exponentials with logs. If you have any other follow-up questions, please let me know as soon as possible. If some of this stuff doesn't make sense, make sure to rewatch the videos, either from this unit or previous unit, since both unit 11 and 12 are very close together. If you have any other questions, please feel free to let me know. You can contact me online, or you're free to actually join my extra help on Mondays and Wednesdays. Have a good day. See you later.